Okay, so the next thing we're going to be talking about is the parameters and variables and functions. These are basically like you would define them in the normal programming languages, but there are a few differences that I just want to point out. So there's a few places that you can do this, either on the global definitions or in the components. And what that is you scoping it. So anything that's defined up by the global definitions are for the model as a whole, versus the components that's localized only to that component. So just like with any other modern programming language, object-oriented programming language, you can scope your variables to help you control things. That's the same kind of idea here, so that you can have different types of variables. Age, for example. Age is a function of temperature, and that will be specific to different components. Same name, different components, overloading, all that good stuff. So under the global definitions, they're almost entirely the same with the exception of this parameters field. Parameters is only present in global definitions, and that's for things that are very general. So, for example, the length of a particular spacing, maybe the ambient temperature of your equipment, but that pervades all of your other components. This is a particularly useful field because when we get later into parametric sweeps, it's going to be the parameters that are defined in this field that matter. So it's a very intuitive interface. What you want to do is under the name, that's the name of your parameter. So let's say H, right? The expression is whatever you want. You can say 10, but you generally can't use variables, including independent variables. So your X, your Y, your Z, your radius, your temperature, you can't use those. What you can use are units. So you could say something like meters here. And this will populate automatically. So now it's 10 meters. You can put in your description. You can say whatever you want in here. It doesn't matter. Console doesn't care about it. What's nice about putting it in here is this units are all over and it's very consistent in console, especially useful for multiphysics when we're going to be mixing length, energy, time. It's nice to have something in there, but it'll also do funny things like this. So you can put in whatever unit system you want. COMSOL has it built in, and it's got you covered. Here, the value you can see, it's adjusted to SI from Imperial. There are options. You can do different systems, but it doesn't matter, right? COMSOL will handle that behind the scenes, which is very nice. If you don't know the name of the symbol, here we put in inch, but you could also say IN. It knows about that. But if you tried to say something like I, what it'll do, you see the units disappeared, and this, if you can see on the screen, it's now a yellow squiggly underneath, and it's throwing an error saying that it doesn't understand what the code for I is. So it'll warn you, keep an eye out for those. It's pretty obvious, actually. It won't give you an error. It's a warning, not an error. So if you go and you run your model and you have an inconsistent units, it's not going to stop your model from running. It's just going to squiggle it, and you won't see those units appear like it does here. Okay, it's a pretty intuitive interface. You can add rows on top. You can add them below. You can delete rows. It's no big deal. You can even save them to a text file and bring them into another model. Okay, so under variables, moving on now, now you can include variables that are a function of other variables, including independent variables. So here what I've put in is f, which the expression is 2 times t. T is time, not surprisingly. The unit for time COMSOL already knows is s, so it's already propagated that through, and you don't even need to put in anything here. What you could do is do something like this. Say t is 1 over hours, for example, times t, and now it's unitless because it hasn't ignored the unit, it's actually canceled them out. So if instead you did something like meters per hour, say you were doing a speed times, and this is a distance quantity, you can put all that in and it'll automatically track it for you, which is super convenient. Okay. You can also have multiple variable fields defined here. So what you could do is something like this. Now you have a conflict here, right? Because you've got f defined in 2 different places. You can right click and actually disable some of these fields. And that gives you a very easy way to move between different sets of variables if you're testing something out. So that's pretty nice. Okay, let's delete that for cleanliness. Now let's go back here. The next thing, if you right click on the definitions again, you can get to functions. when you do expressions and variables, COMSOL handles all the derivatives, which are important for the numerical methods, automatically. With functions, it gets to be a little bit more complicated because now you might need to explicitly state it. So some of the functions are analytic functions, interpolation functions, which are useful for data, piecewise analytic, and you can see all the different types down here. But I'm just going to stick to the first couple. With analytic functions, it's a little bit detailed. You just have to pay a little bit of attention to what it's saying. Function name, let's call it FCN. And the expression we're going to say is x squared. What are the arguments? Well, it's x, right? We're repeating that here and here. And we're saying the derivatives are automatically calculated from this expression, which works in this case. Let's say the units are going to be, let's say, joules. And the units of the arguments, again, it's this unit tracking, is going to be in meters. Okay, we can plot it, and then you get to see a picture of that function too, which is really nice for checking things. If you wanted, you can also change the definitions of how it's calculating the derivative, but in this particular case, it's not so necessary. Again, back under here, if you go instead to something like piecewise, now it's the same idea. What you have to do is specify what kind of function is on what between start and end, and you put in the function. So let's say 0, 1 with x, and 1 to 2 with 0.5 times x. When you plot it, you see that there's a jump, obviously, because it's piecewise. This particular case has no smoothing. We could also manually put in selections for continuous functions, first derivative, second derivative, and you can see what it's doing there according to this parameter. So this is nice if you have discontinuous functions and you need to smooth between them, you can do something like that. Similarly, there's another one here for interpolation. Also pretty straightforward. Let's say 1, this is 10 or 12, 2, this is 43, 3, and this is minus 20, right? When you plot that, obviously that doesn't look very good. So what you can do is determine the interpolation method, let's say piecewise cubic. Now it looks even better. And also we need to say what the extrapolation is. So if you see on the plot here, there's a red dashed line. That's the extrapolation, what's happening afterwards. It's kind of dealer's choice as to what you want to do. And you can also put in your units here. Okay, so underneath the component for this particular scope, it's almost identical. There are a few different options that we're going to go into what the different options are, not in this particular case, but you see you have the variables and the functions, and we'll go into all those other options at a later point. All right, thank you.